at it for a second. It's like looking into the sun. And it pours the molten glass into this colander that's going back and forth, and the whole thing is kind of moving together, and it's spinning cotton candy. It's basically what it looks like.
Fibers of.
Mm-hmm. And it goes down into a big conveyor belt that's about, I want to say it was about 10 foot wide, maybe 12 foot wide. And they, depending on what R value that they were doing, they would spin it towards maybe 24 inches in depth to get a 10-inch material, for example. It was really light and full fluffy. So then it would go through this conveyor line where it would go through a drying process and a compression process. And once it got down to about 200 yards through that process, they were able to cut the material in widths, and they would trim off the excess edges, and they would use all the excess trimming for blown insulation. They don't throw it away.
Wow.
They save everything.
I think it would go back in the pot and get melted down, but why not use it for?
Yeah, the Chowchilla plant, I think, had somewhere around a $10 million filtration system, so that they filtered all of the glass in the air, and they reran it through a pug mill, basically like a pug mill, and took all of the glass and then recycled it again. So all the fibers that got into the air, they were able to recycle them and run them through again.
That's pretty great.
It's pretty amazing process. Yeah.
And so, fiberglass is basically a renewable resource because.
Somewhat.
I mean, is silica sand being made now?
Well, I was reading.
Is the Earth, is nature making silica sand?
It is, and I was reading an article a couple weeks ago that sand is disappearing from our coastlines because we have all the dams that have sealed up all the major rivers, so we're not getting that flow of silt into the oceans. Like if you go down to Mexico, at any time of the year when it's raining, I mean, you fly overhead and you have these big plumes of sand going out into the ocean, or dirt, whatever.
Particulate matter, dirt, the earth washed down, and which eventually becomes sand. It's got to be rocks, right? Pieces of rocks and shell.
But like in Hawaii, you have coral, where the fish are eating the coral and then pooping it out, and that becomes the sand. It's pretty cool there. But this...
but we can't use coral sand.
No.
Glass on it, right? It's got to be silica sand.
Yeah, I don't think there's enough coral sand to create the amount of product that we have.
Where do they get the sand?
That's a good question. Don't know.
Because basically what we're talking about is the stuff that you, besides icing, the bad insulation and the foundation of the insulation trade as we know it, is from a product that's made out of sand. I'm so curious to find out where that happens. So maybe by this thing airs on Saturday, we'll have an answer for where the sand is mined and how it gets to these plants.
Well, they get them all by rail.
Okay.
And they pump it in. They just pump it in, including the recycled glass.
And to make glass out of sand, it's a process of mixing it with something and heating it up.
Heat it up, yeah. It takes a lot of energy to create it.
I wonder how much. It's all of it very interesting physically, just to get to that place. But to get to that place where it's a manufactured product, I'm so jealous in some ways because, I mean, even though you have different applications and different houses and different customers and different, you have all the logistics problems that all of us in construction have, including timing and working with other people, but you are working with one thing in various thicknesses, correct?
You make it sound so easy.
I know, it's so simple. You're so lucky. It's so easy for you. What, tell us about Icynene. What's the deal with, and it's open cell foam, right?
Well, Icynene is a name brand, which is probably going to be going away because Huntsman, who happens to be a large chemical manufacturer in Texas, they purchased Demolac, Lapola, and Icynene brands. So they're all underneath the Huntsman label now, and they're probably going to rename or rebrand the brands themselves to be all underneath the Huntsman name. Not sure what names they're going to come up with, but Icynene, for example, has changed their product names, it seems like about every 3 years. Icing, it was a Canadian company, started in about 1986, and they developed an open cell foam instead of a closed cell foam, which took quite a few years to kind of get out in the market.
And what's the difference?
Well, open versus closed cell. So 90% of the cells in closed cell foam are closed. In other words, they're sealed, and they use a gas to create this air pockets in the material. Whereas the open cell foam is more than 90% open cell foam, and they use it's more of a water-based chemical reaction than a gas that could create these closed cells.
But it does the trick, and so how do they differ? How do they differ? How does the closed cell foam differ? Because you have a closed cell foam insulation too, right?
Correct.
How does that differ from the open cell foam in terms of everything? Is it thicker? Is it a better R rating? I know it's more expensive, right?
Yeah, definitely. So you two products, you're open and closed. They're both capable of being used in any climate, all the way up to Alaska. The challenge with open cell foams is that it allows moisture to go through it a lot easier, and it will absorb bulk water, even though it's a hydrophobic. So in other words, you can put it on top of float it on top of water, and it'll float there indefinitely.
Is that what hydrophobic means?
It's afraid of water.
Okay.
Hydrophobic.
So it doesn't like a
Doesn't,
sponge.
it's not like a sponge. But that being said, if you submerge that same product underwater and hold it there, it will absorb water like a sponge. So that's what when we talk about bulk water, we don't want to put in a bulk water scenario. Whereas closed cell, we can put it underwater and it won't absorb much water at all outside of the 10% of open cells that are on the outside of the foam itself.
What about insulation value, R value?
So our values with open cell typically are 3.7 per inch for what's called half-pound spray foam. They do make a 3/4 pound spray foam, which has an R value of 4.2 per inch. Gives us a little bit of added advantage for those projects with a 2x8 rafter where we need to get an R30. We can get an R30 with the 3/4 pound foam at a less expensive cost. Closed cell foam, roughly nowadays, since it has an HFO, so it has no fluorocarbons in it, has an R value of 6.8 per inch, depending on the manufacturer.
And then how about cost-wise? Is it double?
It's about double. It's about double the cost. And part of the challenges of using either of the products is we want to use a product that will fit the requirements for the specific project. In other words, we want to look at what the Tile 24 report calls out for. Let's say, for example, it calls out for R60. Well, that's pretty beefy. For closed cell foam, we need a 2x10. Not too many people build past 2x10s. I mean, sometimes 2x12s, 11/7/8, maybe 14 inch, but R60 is pretty beefy, so we typically would only use closed cell foam for an R60 value and a 2x10, and that's the only choice we have.
Why would they call out an R60 value?
Well, again, we go back to the fenestration. If it has an excessive amount of fenestration, maybe it's kind of a give or take. Like I'm looking at 2 projects right now that are down in the Malibu area, and they have a lot of block. And they're able to get away with a low R value in the block of an R10. But they have to make up for that low R value in the block walls by going with, say, R31 on the walls that are framed, and then an R60 in the roof assembly. Might have skylights. Skylights can really hurt. But you know, there's a balance there where you have an architectural piece of artwork. You want to build this cool project, but you got to insulate it, and it's got to meet the codes. Tile 24 engineers are challenged by some of the requirements of these complicated houses.
To say the least.
Yes, and you know, between the general contractor, Rodney here, for example, insulation contractor, we pretty much pull together all of the missing links that the architect, the structural engineer, the Tile 24 engineer, and other engineers didn't happen to take the time to talk about and work through the weaknesses in the plan itself. So we both deserve a good pat on the back.
And you need a big picture of the Brook Building.
Oh, the book. Yeah. Well, I have the one in the front of the
You do?
office.
Oh, I haven't
Yeah.
seen it.
We got I won an award for that.
Yeah, of course you did. That's
Yeah.
why I'm saying it. So you won an award, and you got some valuable.
We actually have some new prints coming out on the new metal back pictures.
Yeah,
the
yeah.
really thin ones.
Oh, yeah.
Yeah, we ordered
Oh,
some
cool.
of
Oh, yeah.
some of our projects, and
You know, I'd love to see that. So, I find what we've been talking about so unbelievably interesting because it's become a vital part of construction. It's become a mandated part of construction, and it's also a makes common sense part of construction to me. For instance, when we have an opportunity, patching in windows in a remodel we're doing,
Right.
we're doing an extensive amount of work, and there's X amount of drywall left over. Let's take that drywall off. Let's incur the cost per square for new drywall so we can insulate the wall because it's a better wall.
absolutely.
It's better for sound, better for heat and cold transfer. It's a better house. It performs better.
Well, especially in a house where you're going to come in and do a little bit of rewiring, and
Yeah.
you're going to poke a whole bunch of holes in the wall, and
Yeah.
then the taper's going to come out, and the drywall man is going to go, you might as well just pull all the drywall out because it's going to cost the same.
I know.
And when you think about trying to insulate an existing wall with blown insulation, you're limited on only doing the cavities that are large enough for us to be able to pump the insulation into those cavities. If you have a cavity wall that has a 1 inch or 2 inch opening, there's no way for us to get any product in there. So you have an 85% of the wall will get insulated, whereas 15% won't.
And I think, Dave, what you're to qualify what he's saying about blown insulation, I'm going to get close to your mic here, is that if you have uninsulated walls, you know they're uninsulated, you can go and locate stud bays, poke a hole, and blow in insulation to fill up that stud bay cavity, hoping there isn't a mid-bay block.
Yeah,
Then
we
you have
would
to
check
go
for that.
above and below that, right? And then just patch the holes. So that's something that you guys also do. You blow insulation into existing walls.
We used to. We now sub that out to another subcontractor, insulation contractor, because he specializes in it.
So, plus, who wants to do that? Ugh.
Yeah, it's well, you work with a lot of homeowners, and homeowners they're hard to make happy.
Yeah, but it's a way to certainly a way to insulate your walls that aren't insulated, short of tearing off the interior or exterior finishes. But I also suspect that it's more common that people have their attics blown because of all the wiring and pipes in attics. It's much easier just to fill that thing full of blown insulation rather than try to cut bats. Is that
Well,
is that correct?
That's a good question, and I think really what we want to focus on first for existing homes or any homes, you want to work on the ceiling first, then the floor, and then the walls.
Yeah.
And a lot of people tell me, well, my attic's already done, it's fine, there's no problem. What we've learned over the years of insulating existing homes is that the floor of the attic has lots of penetrations in it from wiring, plumbing, framing, drywall that's kind of pulled away from the studs, or the studs are pulled away from the drywall. The crawl hole cover has no insulation, it has no seal on it. So what ends up happening is we're providing all this heat on a cold day into the house, and the warm air kind of fills up the room and it's pushed up to the ceiling. If it can leak into the attic space where there's open vents that are drawing the air out of the house, it works like a stack effect. It just draws the air out of the house into the attic and out the vents. And it can go through multiple locations, through the plumbing, electrical lines in the interior walls, exterior walls. It can go through the crawl hole cover. That's probably the worst one of all, is the crawl hole cover. So when people tell me that their house is insulated correctly, have somebody go up and look at it, because most homes have had some tradesman up in the attic transferring, draping around the attic floor, moving material out of the way, and conveniently almost never putting it back. So you have all these holes that become the weakest link in trying to control this. Imagine yourself sleeping on a cold night and you pull the covers up and one of your toes sticks out. One toe! You feel that toe. same scenario.
It's a good analogy. So we bring into play the second law of thermodynamics, which is heat seeks cold.
Yes.
Heat rises, heat seeks cold. And they'll
Wet
remember that
equals
from
dry. Or
last
wet
week.
seeks dry.
Yeah.
Yeah. It's.
And then, Dave, the types of insulation. We've covered batt insulation, which is generally fiberglass, but not always fiberglass. The Icynene product, which is which are mostly like what I have at the Mangones is a half-pound open cell.
Open cell, right?
Spray foam. And then what other types of insulation are there?
Well, we did used to have a product called Bonded Logic, and effective, I think the 17th of February 2021, they are no longer producing Bonded Logic, which was the cotton insulation of choice. We found this product, I found it first in about the year 2000 in a Las Vegas convention for the Insulation Contractors Association of America. And it was the best product I'd seen ever of all the cotton products I'd used in the past.
And what
But
is
they're
it?
gone. Now it's a recycle. Now they call it a recycled jeans, but
Yeah,
basically what it is,
Denim, right?
yeah, it's basically all the trimmings left over. They give you the